Okay, I apologize for the delay, but I had too many things going on in the lab at one time to get everything organized. So maybe things will go faster now. We've been working on the all transistorized transceiver, and I built the audio section. I think last time I showed you with a little wire that I got a little popping sound, so I said, no, that's not good enough, let's do this. So here we go. First of all, I have a audio generator. You can buy this little kit for less than 10 bucks. They're either based on the ICL 8038 audio chip or an XR2206. And I think the XR2206 goes to 400 kilohertz or so. So you could, maybe 500, 1 megahertz. They're different. There are different vendors that show different limits, and I'd have to just purchase one and play around with it. But so I'm gonna, this thing, the ICL 8038 chip will work off of something like 5 volts to 30 volts. I'm gonna power this off of 12 something. Here's my power source. I did an experiment 10 years ago or so. I was playing with these lithium-ion batteries, 3.7 volts. Here's a battery holder. I've got 3 of them. I haven't gotten sophisticated enough to put a on-off switch, so to turn things on, I just install the 2 in batteries, and then the middle one, I just push it in, push it down, and now whatever I've got it connected to is powered up. In this case, it's the audio generator. Now the audio generator has a sine wave, a triangle wave, and a square wave. I'm going to use the sine wave. I'm going to feed this through the output. Here's ground and here's plus. Now this thing outputs 3 some volts peak to peak. That's too much. So I'm going to feed the output through a little cap, this cap, so that lowers the output voltage to my transceiver to a few millivolts. I don't want to overpower it. I'm going to power my transceiver with another lithium-ion battery, and I've had this one for 15 years. I bought a couple of them for 10 bucks each at a swap meet in Phoenix. I've got it hooked up to a 2.54 millimeter header. So let me move my little transceiver into the field of view here. Oh, and this goes off to a little, let me measure it here. I think it's 6.5 centimeter speaker that I've had, you know, again, something that I picked up somewhere over the years. So here's my transceiver with the audio section wired up. I'm going to feed the audio signal into the transceiver at the source or drain from transistor Q26. Sorry for the shadow. Through, this is C7, and then here's Q26. And then this feeds the rest of the audio amp. So let's quit fooling around here and let's just do it. So here's my turn on switch, and there you go. It's still too loud. Let me vary on the audio generator. There is a frequency control so that I can lower it. This goes around 200 and some odd hertz, and you just run it up. Now what I could do is you can take some data by measuring the output from the speaker to find out what the response is for the audio amplifier, and I'm going to run this all the way up. And I think that's over 2 kilohertz. And as far as my ear can discern, it's pretty much constant volume, and it's loud. So I need to decrease the size of the little capacitor to reduce the input to the amp. Okay, I hope moving a thing around here doesn't make you sick. So that's it. We're up and running. So now we're going to go to the next step. Let me show you how this is kind of silly. Here's how I turn off my little audio generator. So let me move everything around. Let me show you the schematic. We've got the audio amp. Next thing to do is the mute. Now in order to do this, and I'm going to give you the exercise and I'll do it, and when I come back with it wired I'll show you exactly all the parts, but I'll trace the circuit. What you do is everything to operate Q26 involves R2, R3, R7. Here's a cap here, 100 nanofarad diode, and then the signal line or the mute line goes around all the way over here, down here. So you're going to need R9. I'd go ahead and put C4 in here. It won't matter. Then you've got C22, Q6. We won't do the band pass filter right now. Q9. Then there's some more stuff here. Q10, R28, C39. Then D7. And this enable line here goes to the key line. I don't have the transmitter thing here, but wire all that up. Now the way the mute works is you've got your receiver connected to the antenna. What else is connected to the antenna? Well, the transmitter. When you key the transmitter, you're going to have 2 or 3 or whatever the power output from the transmitter is going to be. That's probably going to be about 3 watts or so. It's going to be at full intensity here, and I want to keep it from going through the rest of the receiver. The way you do that is you turn off the input to the bandpass filter here, but there's still going to be some signal that's going to be manipulated by the receiver, and the output from the receiver is going to go up to and through this coupling capacitor into this part, and then this is part of the mute circuit, and this will turn off the input to the audio amp. Now there's a little bit of signals come through here, and what this does is this allows you to hear your signal at a very low volume, hopefully, and you can monitor and copy your own code as you're sending. And because there's no relays or anything going on, when you are not transmitting, then the mute signal is off and noise and the signals on the air are coming through the receiver and you can hear them. Then when you key down, the only thing you hear is your tone or your signal in the audio amp. You quit keying, signals from the outside world come back, and this is called QSK, which means that you can hear everything that's going on in between your dits and das, no matter what the speed. And this allows the other station to key down. You'll hear his signal or her signal come on, and you will stop sending, because that means it's like someone interrupting you while you're talking and say, wait a minute, and that's what they want to interrupt, and something's going on, they can't hear you. There's a station interfering with your signal that you can't hear, and they're going to ask you to wait just a second, and they may try to contact the other station. There's all kinds of scenarios. So that's a brief overview of the mute circuit. let's go off and wire it, and we'll come back and test it. Now the way I'm going to test it is I'm going to, now I can't do anything over here, but what I can do is I'm going to take my little audio generator and feed it right here, so that that will act like the receiver's working. And when I key, when I take, we'll show you in the transmitter where I'm going to take and short the input to ground, which is the same as taking a straight key and closing the contacts to send. And that should reduce the audio. Okay, this coming from the receiver or from my audio generator through this coupling cap. This will attenuate it as much as possible, and we will hear the tone in the speaker reduce significantly. Now, one of the things I'm going to do is, I don't like the speaker. I'm going to take the speaker off and connect it to a small powered speaker, which is what we're going to be using anyway later. So, okay, enough said. Let's go and build, and I'll be back today. Today is March 31st, the last day of March. We're down 3 months, 9 more to go for the year. Thank you, and please keep coming back and keep liking.